All right. Good morning, everybody. Welcome to another Random Code. I still have a cold, which is showing up because my cognitive skills aren't all there. This should be called part two. I named it incorrectly as part one, but this is part two of this playthrough. It's kind of a combination of coding and playing a game, so to speak. But isn't that what coding is? So I will change the title once the stream is done. That this is this the day two second part of getting into Random.Code. And yesterday I got through both parts of days 1, 2, and 3. So we'll see how the next series of problems goes. As I said before, I have a cold, and my voice is still like I was listening to the stream a little bit yesterday just to hear how it sounded. And yeah, my voice is definitely not up to snuff. My older son and I have a self-defense lesson this afternoon, but he's also getting the cold now, so we may decide to cancel it until next week. We'll see. But in any event, let's see. Where do I want to go? Well, obviously I'm going to go to day 4, but one of the things too that I've been trying to keep in my head is, which parts could I potentially come back and do some optimizations on and keeping notes on that kind of stuff. So that's something that I want to do. One thing that I put down for my notes on day 3. Can I make the reg X's any better, especially for part 2? Okay. All right. So let's clear the deck. Go to Random.Code here, and let's load up. Oh, before I do that, let's get some music going. Having the background there. All right, so day 4. Cirrus search. Excuse me. Looks like the chief's not here. Next, one of the historians pulls out a device and pushes the only button on it. After a brief flash, you recognize the interior of the Cirrus monitoring station. Keeps referencing back to previous Advent of Day problems. As the search for the chief continues, a small elf who lives in the station tugs on your shirt. She'd like to know if you could help her with her word search, your puzzle input. She only has to find one word, Xmas. 'Tis the season. This word search allows words to be horizontal, vertical, diagonal, written backwards, or even overlapping other words. It's a little unusual though, because you don't merely need to find one instance of Xmas. You need to find all of them. Here are a few ways Xmas might appear, where irrelevant characters have been replaced with a period. Okay, so here you've got let me zoom in on this a little bit. Here you've got a diagonal. Here you've got backwards. Here's forwards. And then here's up. Okay. The actual word search will be full of letters instead. I'm smelling a span coming up here. Maybe. The actual word search will be full of letters instead. Yes. In this word search, Xmas occurs a total 18 times. Here's the same word search again, but where letters are not involved have been replaced with. Okay. You have Xmas. This is a little interesting with this one. XMAS. XMAS. This is what I don't understand. Like, why is this? Oh, because you're going this way. Ah, okay. So you go that way and that way. So you have to check 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. 1, 2, 3, 4. 1, 2, 1, 2, 3, 4, 5, 6, 7. Yeah. A total of 8 directions. Now here is a little bit where I get what you're doing. You basically have to go through each you have to go through each what's the way I'm trying to say it, direction, assuming that you can actually get there, because if you're at the top here, you can't go up, so you have to have enough room to go in that direction, if that makes sense. So like if you're at the edge here, you can't, the thing was, I was wondering is, can you wrap around? And I don't think that's what's allowed. So basically you have to say, if I find an X, then can I go like left? Do I have enough space? And if I do, get all the 4 letters and then say, does that equal Xmas? And then like I could say go west, go northwest, go north, go northeast, have them actually as 8 directions. And then say, if I'm at a particular location with an X, can I go west? And if so, does west give me, enough what's the word I'm looking for? Enough characters. So let's go get the puzzle input. So we need to know how long it is, and the thing I was thinking too is, well, do you necessarily need to keep, like, do you need to load every if I loaded all this up as a character array, I don't think it's going to be that much. Like if I say save as day 4 input text file, and if I come in here, I can tell you how big the file is. No, it doesn't. Okay. So yeah, it's only 20K. So loading that up in an entire array, it's going to be a multi-dimensional array. Is it that big of a deal? Excuse me. Probably not. We could just load them as strings instead of trying to, have an array of strings. We know they're all going to be the same length. We know how, we're going to know the size based on how long a string is and how many lines there are. And then we just search for X's in each string. And then we determine which character we need to get in a string. Can you... I'm just curious. If I say like var x is equal to new string x. Yeah, you can index into a string. So I thought you could. I just want to make absolutely sure before I go down a path here. Not 34, 4. So again, we'll take our immutable array of string. And we do want to return a count. So we want to have like, at least in here, var x miss count is equal to 0, return. Here we're just going to say the same thing just to get the compiler to shut up because it doesn't like that. We don't have this here. We don't need that, and we don't need this to be partial anymore. Okay, so we have an array of strings. Public enum directions. West, north, west, north, northeast, east, south, east, south, southwest. There. So we know var x max is equal to an input 0 length. We know that's the max length. And then var y is the length of the whole input. Okay. So now we need to say here, and we need to keep track of var. Come on. No, we want these to be x max. And actually we want this to be, we want the y to be going down with each. And then for, oh, come on, you can't finish that. Okay. So we're going to say if. Well, we could say here we could get the line. Var line is equal to input of y. And then we could say here if line of x is equal to an x. Now we got to start searching. If it's an M, it's an A and an S, we don't care. So the first one we could do is west. This is going to end up being like 8. I don't know if I'm going to actually need that enum or not. If x is greater than or equal to 3, we can do it. Well, we could say, and This is going to look ugly, but so now what we want to do is we want to go capture line of X, line of X minus 1, line of X minus 2, and line of X minus 3. Is that equal to, and our constant should be private const string. Does that equal Xmas? There. So we made sure that we were at least 3 over. 0, 1, 2, 3. Doesn't matter how much farther we are at the end of the string. And then we just go backwards. Not maybe the most efficient way to do it, but now we want to say northwest. We need to be X is 3 and Y has to be greater than or equal to 3. And yeah, now I need to index back up into the previous strings in the array, but that's okay. So we're going to be here. And now we need to go to our input. Because we need to hop up 1, and then we need to grab X minus 1. Input, we got to hop up 2. And we need to get X minus 2. This is where input Y minus 3, X minus 3. Yesterday somebody saved my butt because they noticed that one of the problems didn't have the same input, test input. It's always the same file, but the test input for part 2 was different. And it was throwing me off, and they're like, hey, I think you actually have your regular expression right-ish. It's just that your input isn't right. I was like, oh, yeah, thank you. So this is where something can easily bite me because I'm not necessarily now we want to go north. North doesn't care about how far X is. We just need to make sure that Y gives us enough space. And so now we're always going to be grabbing like line X. We're going to go up, but we're always going to be getting X to X 3X. Okay. Now we're going to be doing northeast. So this case, X has to be less than or equal to, oh, that's a great glyph there. So let's say we had a string of length 10. We need 7, 8, 9, 10. So would this be less than or equal to X max minus 3? Because if we had a string of length 10, and I said 3, 7, which isn't right because, again, everything is 0 based. Because if I said 7, I would do 7, 8, 9, and 10, and that would fall off and that'd be too far. So you have to say 4 here. And is Y also well, yeah, I think here I still say 3. Because I want to be 3, 2, 1, 0. Same thing with northeast. It doesn't, I just need my string and the 3 above it to make sense. But if I had a 10 length string and X was 6, that's okay. Actually, if I did this, if I said strictly less than 3, that might be actually a little bit more consistent to read it that way. Because then if I had 6, I could do 6, 7, 8, 9. Because 10 minus 3 would be 7, so that'd be less. If I had 7, 7, 8, 9, I couldn't do 10, but that will stop it. I like that better. I like doing the exclusive and inclusive ranges. This again just makes sure that we're at least 4 rows down. So in this case, we're going to get line of X. Then we're going to get Y minus 1, but we're going to get X plus 1, Y minus 2, X plus 2. And then Y minus 3, X plus 3. And then east is almost like west. Right? So now we need to say if this condition and now we just say X plus plus plus. There we go. So we're 5. We're 3 away, hopefully. If I didn't screw up any of the math here. I'm guessing there's a way that you could optimize this, so you could like read in. You always have to have 3 above. Well, depending upon where you are, like you can start shifting things in and then just keeping like a window over all those so you don't load all of them in. I don't know if I'm going to be that efficient with this. So west, northwest, north, northeast, east. Now we need southeast, which I would assume is almost like northeast, southeast. So in this case, we need to be going down that way. So we do need to make sure we're at that max. But now Y also has to be less than Y max minus 3. Because we need space below us. And so again, we get our line of X. Actually, I just realized we can make a slight optimization here because we don't need to, we already know that line of X is equal to X. So there's no reason to keep re-indexing into the string to find it. Okay, so we get X. Now we need to go 1 line down and 1 line over, 2 lines down and 2 over, and 3 lines down and 3 over. And actually, I don't even need this extra character here. I could just say target word is equal to mass. And I don't even need to put that in there then. Again, these are very slight optimizations compared to what I could probably do. But these should work. Now I need to go south, which should be like north, except flipped. So in this case, we need to make sure that we are enough space below us. So we have our X, we need to do +1, same position, +1, +2. And then southwest is sort of like northwest. This is bringing up nightmares of the 2022 one where you have directions and I would always get them screwed up. So again, now we need to make sure we have enough space to go west. We also need to make sure we have enough space below us. And so now we need to go down 1, but back. We need to go down 2, back 2. We need to go down 3, back 3. There, shut up. That part 2 is obviously wrong. I don't even know what it is. Let's just remove the directions here because we don't need them. Apparently. Let's see what this does. Comment about part 2. And so we can use this is supposed to be 18. And do we have on this one to split so we can get our magical thing? So here we're going to say that we split on that. This should be, I said 18. This is probably going to be wrong. No. Okay. That's a little shocking. I was expecting to have like some index out of range or something like that happen. So I'm a little shocked at that one. Day 4. Day 4. Let's comment this out and say 4. And we need to have day 4 input. And then what does it tell us? Is that the right answer? That's the right answer. Holy crap. Holy crap. I can't. Don't. What's the phrase from Star Wars? Don't get cocky, kid. Don't get cocky. I did not expect that to work, like out of the gate. I'm just not. I'm old enough to know I can mess things up rather easily. So, all right. Part 1 of day 4 is done. What's part 2? The elf looks quizzically at you. Did you misunderstand the assignment? Looking for the instructions, you flip over the word search to find out this isn't actually an Xmas puzzle. It's an X-mass puzzle, in which you're supposed to find 2 mass in the shape of an X. Oh. So MAS, MAS. And I'm guessing, yeah, here's an MAS. Here's a, sorry, let me zoom in on that a little bit. So like here's an MAS. Here's an MAS. Here's an MAS. Here's an MAS. So the M, the mass part, MAS, can be in any direction, but only on the diagonals is the way I'm looking at it, because that would form a cross or a plus sign. It wouldn't form an X. So now we got to be a little different. Now what we want to find is XMAS. So we want to find an A. And so we can look at one diagonal, as long as we have space above and below, and say, does that equal mass or SAM? It doesn't matter. It can be MAS or SAM. And then we look at the other diagonal. We have enough space. Does that equal mass or SAM? So kind of like this, except way differently. MAS word, and then we're going to have our SAM word. Okay, so in this case, we go through, except now what we want to find is an A. Okay. And so what we want to do is say, if line of X is A, and I guess you could make the optimization here to not even do, like one of the things I just realized here is you could almost make this so you don't, yeah. Let me put that as a note. Day 4. Could make the for loops bound such that we wouldn't have to check to see if X or Y are within limits. E.g., X is greater than or equal to 3 or something like that. Okay. I will leave it this way for now, but that's something I just noticed, is that you don't need to you can constrain it so that you're only looking for places where it could possibly happen. Although, no, actually, no, you can't do that, because like Y, you could go straight down. X, you could go straight across. So no, that's not an optimization you could make. Okay, so we find A, and I guess in this case, though, this one, for part 2, is like for X is equal to 1, X is less than X max minus 1, X plus plus. So something like that. But again, I'll keep this the way it is for now. So if the line X is A, and, well, why don't I just do that? Why don't we just say for Y is equal to 1, Y is Y max minus 1, and then X is 1, and then X is max minus 1. So we don't even have to make that check. We're going to always know that if we find an A, we have enough space around it in any direction. So again, I can take this off. It's actually the right way to do it, in my opinion. And so now we get we'll get one of the diagonals, and it doesn't matter what. Word 0. It really doesn't matter what it is. And I guess we could also say it could be SM or MS. Do we really need a constant for that? I don't know. So what we want to do in this case is get input of the Y above us, the X previous, and then we want to get the Y below us and the X after us. So it goes, that's the one I'm getting there. And then word 1 is we go above us, but we go ahead of us, and we go below us, but we go behind us. So if word 0 equals SM or word equals MS, so that's one condition. And word 1 is equal to SM or, come on, God. Word 1 is equal to MS. X miscount plus plus. Can you give me an optimization here? Nope, can't pull that out. Okay. It's odd that this almost seems simpler, but I don't believe it is. Okay, so let's go back to make sure we have same example from before. Okay, so except we're going to say part 2, 9. That's how many crosses appear, and that's what we're looking for. Okay. We're on part 2. Is that right? Day 4 is done. Okay. Progress is being made. So part 2 of day 4 is complete. Okay. That's weird because I always have interpreted part 2 as being a little like slightly harder than part 1. But in this case, part 2 feels a lot simpler than part 1 is. So, I don't know. But whatever works. Okay. Onward and upward. So let's go to our advent calendar. I think there's a Christmas tree happening here. What do you think, people? Think that's a Christmas tree that's going to be here? I don't know what this is yet. Oh, that's Rudolph. Isn't that Rudolph? The eye and the red nose. That's my guess. Bryce, happy holidays. Same to you, Bryce. What's your objective here? Win everything. My objective is just to have fun. I'm on vacation. So there's a couple of objectives. One, have fun. I'm on vacation this week and next week, so I'm just having fun this week. The second one is just to do something different
with streaming in terms of what I do for coding. I did Random.Code 2022. That was the first one I did. And I didn't stream that. And my goal was to finish each day on the day, not in any time, but to get it done on that day. And that was sometimes easy and sometimes really brutally hard for me. But I did it. At least I did it. And so if you look at my channel, you'll find a video from a couple years ago where I kind of break down what happened each day. With this, I'm just streaming it just to see what people get out of it. And people have questions or like, hey, why'd you do this? Or like I said yesterday, somebody named Guy, he saw that I had the wrong input for part 2. So, which then once I changed that, fixed everything. So that helps. So just that's the objectives. All right, print queue. Satisfied with their search on series, however you say it, the squadron of scholars suggests subsequently scanning the stationary stacks of Sub-Basement 17. Jeez, it's a lot of S's. The North Pole printing department is busier than ever this close to Christmas, and while the historians continue their search of this historically significant facility, an elf operating a very familiar printer from 2017 day 1, a very familiar printer beckons you over. The elf must recognize you because they waste no time explaining that the new sleigh launch safety manual updates will print correctly. Failure to update the safety manuals will be dire indeed, so you offer your services. Yeah, Random.Code. You can see the link up here, adventofcode.com. Check it out. You can go back to any year, and it's just a good way to like keep the brain working. I've always said that I love puzzle games. I love solving puzzles. I also think I'm not the greatest at it. And so I like doing these just to keep my skills as sharp as I can. I remember when I did 2022, one day I tried to solve it as fast as I could to get on the leaderboard, and that was ridiculously not even worth it. Some people just, I don't know if they were using any AI or they're just that good at what they do. But I couldn't solve these in seconds. There's no way. So I just couldn't do it. Anyway, so yeah, you can get a whole bunch of problems just to try, and it's good to also see if you can do them in a different language. I'm considering doing that in 2025, is picking up a different language other than C# and doing it that way. Anyway, safety protocols clearly indicate that new pages for the safety manuals must be printed in a very specific order. The notation X pipe Y means that if both page number X and page number Y are to be produced as part of an update, page number X must be printed at some point before page number Y. The elf has for you both the page ordering rules and the pages to produce in each update or puzzle input, but can't figure out whether each update has the pages in the right order. So we have a bunch of X pipe Y values, and then we also have a random comma list. The first section specifies the page ordering rules, one per line. The first rule means that if an update includes both page number 47 and page number 53, then page number 47 must be printed at some point before page number 53. 47 doesn't necessarily need to be immediately before 53. Other pages are allowed to be between them. Okay, I guess you could just order them. I don't know. The second section specifies the page numbers of each update. Because most safety manuals are different, the pages needed in the updates are different too. The first update means that the update consists of page numbers 75, 47. To get the printers going as soon as possible, start by identifying which updates are already in the right order. Oh, okay. I think I'm starting to get this. I think 75 is correctly first. Oh my god. I was trying to think how to do this one. Because there's a rule that says 75 must be before 47, 75 must be before 61, 75 must be before 53, and 75 must be before 29. 47 is correctly second because 75 must be before it. And every other page must be after it, according to 47. Okay. '61 is correctly in the middle because 75 and 47 are before it. 53 is correctly fourth because it'd be before page 29. Because the first update does not include some page numbers. The ordering rules involving those missing pages are ignored. The second and third updates are also in the correct order. Like the first update, they also do not include every page number. So only some of the ordering rules apply within each update. The fourth update is not in the correct order. It would print 75 before 97, which violates this rule. For some reason, because DLs also need to know the middle page number of each update being printed. Because you are currently only printing the correctly ordered updates, you'll need to find the middle page number of each correctly ordered update. In the above example, the correctly ordered updates are... These have middle page numbers of 61. Adding these together gives you 143. The actual list of page ordering rules is bigger and more complicated than the above example. Really? I would be shocked. Yeah, that's a little bit bigger. Save as day 5 input. Okay, so I think what we need to do is look at each line. If it has a pipe in it, then we know it's a rule. And so we can just create a rule that says what's the before and what's the after. So it means like before, like in this case, 47 has to be before 53. Okay. It doesn't matter if there's 10 pages in between, 47 just has to be before 53. So we get all of the rules. And then we get the updates. And with an update, what we do is we say, we split it and we get each value. If there's nothing before it, then we have to say, is everything after it okay? It doesn't care about what's before it in that case. Like, you know, it's here, 75 does have a rule to say 97 has to be before it, but it doesn't mean it has to be strictly before it in each update. So we just say, we want to find a rule where the before is the value we're at, and the after are all these. Now, I'm guessing it only gives you Well, the thing that went through my head is, what happens if you have, like, I don't see a 20 here. So what happens if you had 47 here and you have a 20 after? Well, that doesn't have a rule in here. So is that okay? So to look at the list, you have to say, how's the right way to do this? Do you want to like in this case, 75-47, you have to find a rule that says that 47 has to go before, 47 has to go after 75. You also have to find a rule here that says 61 has to go after 75. When we check 47, we have to find that there is a rule that says 75 has to go before 47. If we can't find that rule, then we know it's an invalid update. Okay, I think I'm getting my head around this. So we're definitely gonna have to do some more parsing. I don't know, var middle page count. Page count sum. Return that. And then we're here, we'll say Rx is equal to 0. Oh no, we'll say it's input. Just to get the compiler to shut up. Okay, so what we need is a public struct record. Or is it record struct? I can't remember. I think it's record struct. Rule, which is an int before and an int after. And I believe that's what's complaining about. Okay. And then we need a well, the updates are just a arbitrary length size array. If I remember right, these can be, yeah, they're going to be odd. They all have to be odd because you need a middle page number. But we can examine each one. Okay. So I don't think we need a separate struct for that. So the first thing we need to do is say for each var item input. We don't know if it's a rule or an update. So we're going to want a var rules is a list of rules. We also want updates to be a new list of int arrays, not pointers. Not updated, updates. Okay. If item contains a pipe, you're going to do that crap again. We know it's a rule. So we're going to say rules.add new rule. We're going to say var rule values is equal to item split. And then the rule is the rule int.parse of rule values 0. Culture info. And then the same thing except for 1. Okay. So now we've got the adding of the rule. And then we're just going to assume that we have an update in this case. We're going to assume that with our input. So we're going to say var update values is item split except on a comma, right? Yeah. And then we can say select, because this is going to give us exactly what we want. We can say int.parse to array, and then we say updates.add update values. There. So now we're going to be splitting. We're going to be getting our rules, and we're going to be getting our update values. So now we've got our structures. Now we need to go through each update value and determine if it's a valid order. So as we're going through each value, we just need to say grab all of the previous and see if there's a rule that exists, and then grab all the nexts and see if there's rules that exist. Easy. For each var update and updates, for var equals 0. Well, that's wrong, but update.length, which we don't know what that is, but that's fine. Okay, so how can we do this in a generalized way? If I is greater than 0, then we can look to the left. So if I is greater than 0, we can look to the left. And then we can get all our rules checks that way. Else, if I is less than right, because if we had 7, if we had a string of length 7 and I was at I, if I was at 5, I could do it because I gotta get to 6. If I'm 6, I can't go to the right. We can look to the... By the way, just a quick update. If you haven't subscribed to the channel yet, please do so. We'd greatly appreciate it. Trying to hit that first milestone of 1,000. Slowly but surely getting there. So if you wouldn't mind doing that, I would appreciate that. So we're gonna now get to check all these. Okay. So what we can do here is these are afters. So we want to say for var afters is equal to 0. Afters has to be less than I, a plus plus. If it doesn't exist that in our rules any equals a new rule, no, not A and I, in our update at A and our update at I. If there aren't any, what I really want to do is just completely get out. Because there's no point in even looking at anything else. If you can't find that rule, then that's not a valid ordering. So how do I want to handle this? If there aren't any rules like that, then I'm almost saying use a go-to. Which would be extremely wrong, but that's almost what I want to do. You just want to get out of all of this. I can't believe I'm even considering using a go-to. Have a reaction video that somebody else makes. We need to talk about this. Somebody use a go-to in their Random.Code. But it makes the most sense to me. Var is valid update. We're going to assume it's true. But if we're proven false, we're going to say is valid update false. Go to do add God. I just threw up in my mouth a little bit. Is that how you do this? Jeez. Wow. Okay. I feel horrible as a human being, and, you know, God. If is valid. And then we take our middle page sum plus equals update, where what we want to get is that middle value. Ant.floor. I don't want the remainder. I want update length divided by 2. But I don't remember. Ah, that's how that works. Okay. What happens if we say 7 divided by 2? It's 3. 0, 1, 2, 3. That's what we want. If I say 9, it would be 4. So it floors, it puts it down. Okay. Got it. Just want to make sure on the visibility rules what it does. Okay, so we can look to the left. And we want to make sure that anything that's to the left has a rule that matches that. Now we can look to the right. And so what we're going to do here actually, this needs to be a B. Because we want to do after. So what we want to do here now is say A is equal to I plus 1. A is less than update length A plus plus. And so now we need to find a rule where we find if I is before A. A. If we don't, we toast, we bail. Let's go through this again real quick. So if it has a pipe, we know we have a rule. So we split. We get the rule saying what needs to be before and what needs to be after. Otherwise, we know we have an update. So we split in the comma, we turn them all into integers, get an array, add that thing. Go through all the updates. We assume they're going to be true. And now we validate that. So first we look to the left if we are in a left position. And if we can, we're going to go strictly before. And then we're going to find if there's a rule where the before and or after exists. Excuse me, Jesus. If there aren't any, we're immediately invalidated and we're done. Otherwise, we're going to look to see, can we go to the right? Having a cold sucks. Yes, and so now we're going to see if our current position and the ones after us, if there's any rules. Because it doesn't matter if there's anything in between. And if we have a valid update, we're going to grab the middle value and we're going to add them to our sum. Is this correct? No, it never is. That's one thing I learned early on as a developer. You're never right the first time. If you are, you're doing something wrong. You got to question yourself. Okay, so what is our input here? This. And we're saying that when we run that, the right answer should have 143. Is this correct? No. Yeah, it failed. Awesome. The input, it was not in the correct format. Wow. Oh. I bet it's that one. Else if forgot about that. Nope. We gotta make sure it has a comma in it. Now it passes. Okay. Okay, let's see. Do we ever run day 5? So comment that out for a second. I'm going to say this is 5. Make that 5. And make that 5. Is that the right answer? Ah. Okay. I believe you. Part. Part 5, or part 1 of day 5 is complete. Okay, what's the second half? Well, the L's get to work printing the correctly ordered updates. You have a little time to fix the rest of them. For each of the incorrectly ordered updates, use the page ordering rules to put the page numbers in the right order. Oh, bite me. For the above example, here are the 3 incorrectly ordered updates in their correct orderings. After taking only the incorrectly ordered updates and ordering them correctly, their middle page numbers, find the updates which are not in the correct order. So now we've got a I conceptually know in my head what needs to happen. I just don't know off the top of my head how to do it. So basically, it's like this. It's run part 1, except we need to flip it. And we say if it isn't valid, then we need to get the middle page sum. But we have to sort the list such that it actually is valid. I think it's just as simple as if you find something that's incorrect, you just have to flip it. Because let's say we found in our update array that we found an X and a Y, and that was valid. Okay, it didn't matter how much is in between it or if nothing's between it, those are valid. If there was something before it that said, like, Q couldn't be before X, we can swap Q and X around, and then that rule is correct. The other rule is still correct because X is still strictly before Y. And so that should work. So you just go through, and when you find that something is invalid, we don't go to do add because we gotta correct everything, I think. If we don't find any that match this, then we just flip it. And we assume then that there is a rule for that. Hold on. I lost myself. And so I just flip it. And then I can assume that there would be a rule in there. If there isn't, that doesn't match the flip, then we're really in trouble. So we're going to do a lot of copy pasta here. But we still also need to keep track if it's a valid update, because if it was if it was valid in the first place, then we don't want to count it. We only want to count invalid ones, but we've got to reorder the array so that they are valid. Except we got to be really careful here. What happens if you were like not next to each other, but they were apart? So what I'm getting at is, let's say we found like A, B, C, D. And we did a rule that said C had to be before D, okay? But B had to be after D. So if we flip them for B, we're going to get A, D, C, B. Right? But now we're going to get a rule here that says D and C need to be switched. So it's going to be A, C, D, B. But that's still okay because we still have B, and I know they're supposed to be odd length, but we still have D before B. I'm a little hesitant about this, but I think if you just keep swapping them, that's okay. Thank God I did this correctly, which is just to take a look at what they're there, and then I can just swap the two. So we no longer want to do this. Thank God we don't have to go to do add. Jeez. And then we get rid of that. Okay. Did I even strictly need these here? No, I didn't. All right, so we want to say var before is equal to var after is equal to. Nope. If there aren't any rules, we do have to flip the flag because we knew it was an invalid one. But now we say update B is equal to after and we say update I is equal to before. And we just flip them around. And so in this case, this is now I, and after is A. We know it's false, except now the before becomes the after, and the after becomes the before. I'm making some assumptions here that I don't think is right. So now we say if it's not a valid input, we do the middle page sum. So this should be what did it say? This is 123. Except we need part 2 here. Huh, it passes. Really? 5, 5. Okay. We move. Part 2 of day 5 is complete. Awesome. Dare I do one more? Yeah, I mean, if I don't get through it, doesn't matter. I'll just pick it up in the next stream. So I'll go on for a little bit longer. My voice is really starting to get shot. Let's look at the calendar. And there's a little stump of the tree. I can't tell what this is. That's got to be Rain. That's got to be Rudolph. All right. Guard Gallivant. The Storians use their fancy device again, this time to whisk you all away to the North Pole Prototype Suite Manufacturing Lab in the year 1518. Because why not? Was that a link? Oh, another problem. It turns out that having direct access to history is very convenient for a group of historians. Be convenient for a lot of things. You still have to be careful of time paradoxes, and so it will be important to avoid any from 1518, while the historians search for the chief. Unfortunately, a single guard is patrolling this part of the lab. Maybe you can work out where the guard will go ahead of time so that the historians can safely search. You start by making a map of the situation, for example. The map shows the current position of the guard with the caret to indicate the guard is currently facing up from the perspective of the map. Any obstructions, those are obstructions, those are the asterisks or the pounds. Lab guards in 1518 follow a very strict patrol protocol which involves repeatedly following these steps. If there's something directly in front of you, turn right 90 degrees. Otherwise, take a step forward. Following the above protocol, the guard moves up several times until she reaches an obstacle. In this case, by the way, the he, she thing there in writing, I've actually just said use they or them because then it's simple. You don't have to worry about like preferring one gender or making sure you're using he or she. You can just say, the guard moves up several times until they reach an obstacle. Easy. Not trying to say anything there, just saying that I think that's the easiest way to do it. The guard moves up several times until she reaches an obstacle. In this case, whatever it is, you don't care. Because there's now an obstacle in front, yep, they turn down, or they turn that way. So if you go up, you're going to go right. If you go right, you have an obstacle, you go down. If you go down, you're going to go left. And then on the left, you go back up. That's to me. To you, it'd be the other way around. She turns right again and continues downward. This process continues for a while, but the guard eventually leaves the map area after walking past a tank of universal solvent. By predicting the guard's route, you can determine which specific positions in the lab will be in the patrol path, including the guard's starting position. The positions visited by the guard before leaving the area are marked with an X. In this example, the guard will visit 41 distinct positions on your map. Predict the path of the guard. How many distinct positions will the guard visit before leaving the mapped area? So each row in the map, you can keep track of indices where there are obstructions. You don't actually have to contain the whole array. And so, for example, like this, you would just say there 0, 1, 2, 3, 4. Now there could be more. I bet if you look at the input here, yeah, like some of these have tons of them, which is not to be unexpected. Yeah. So for each one, we'd have an indice to say there is one there. Okay. So we could keep track of, we have a list of rows, but the rows are just arrays that tell you where the obstructions are. We do also need an empty array for something like this. We find out where they're starting from here, and we start the position count at 1 because that's where you go. So then you say, okay, I would imagine there's the, yeah, that's where it is. Okay. So you find out where it is, and you know, so you start at 1. Well, not 1. You start with the position count as 1. You also know at your current position what row you're on and what your index is. And then you basically say, do this until I either hit a row of 0, because I would fall off them at the end. X is 0. X is the max length of the string, or the row, or Y, whatever you want to call it, is at the max. Okay. So you basically say, if my direction is this, can I move one ahead? So if I was going up, I would look above me and say, does it contain the index? If not, I move up. So my current position, my point, we can say X and Y. My point would now be the same X, but a Y minus 1. And I can update the position count because I moved. And so I can just have a while loop that says while not X is 0 or X is equal to the max, and or Y, you know, one of those conditions where you're at the edge. If I look in whatever direction I'm going and I see an obstacle, I don't move, I just change my direction, and I don't update the position count. So every time I go through this, I say, can I move? And either I move and update the position, or I change the direction. And then as I go through the while loop, I'm always checking to see, did I hit the end? Makes sense to me, but again, whoops, 6. Clean it up a bit. Okay. So here we're going to have var positions is equal to 0 return positions. We don't know what this is going to be yet, so we're just going to say put length. Okay. So we're going to need an array I mean, this is a jagged array, if you want to think of it that way. But I don't want to think of it that way. I want to say var map is equal to a new list of ints. Stop it. Where input, we know that's our capacity. Okay. So I'm going to say for each our item and input, we want to find where all of the obstacles are. I was trying to see if there's a quick and dirty way to say you want to select you want to find where the character is an asterisk, but then you want to select that index. And I don't know how to do that offhand. Var indices for I is equal to 0, I is less than item.length, I plus plus. There may be a linkish way to do this. I just don't know what it is. If indices, no. If item at I is equal to an obstacle, then we say indices add the index. So now we're going to say map, nope, map.add indices to array. Yeah, you're going to tell me to simplify that, aren't you? Yes, you are. Okay. So now we've got our map. But I want to change that to a row. And what we want here is our classic point structure. So what we want to say here is else if is equal to the up. We found the var guard is equal to, well, we don't, point guard. Now we want to say guard is equal to a new where it's I and R. I is X. It's not unnecessary. I'm going to use it later. Bite me. Public enum direction up, down, left, right. Thank you. All right, so now we have our map. We know where the guard is. Positions is always going to be starting at 1. What did I say? What did I say? Now we need to do while guard.x is great, while not guard.x is equal to 0, or guard.y is equal to 0, or guard.x is equal to, we could say greater than or equal to we could grab, yeah, hold on. Var max x is going to be input of, yeah, god damn, it had it. There we go. Nope. It's the map's length. Count. Max y, or max x, or guard.y is greater than or equal to max y. I know why it's complaining. And I can't say guard is equal to default, because 0, 0, well, no, because if you're 0, 0, then you are at the end of the map. You're at the top left corner, and something went haywire, which I guess would be fine if, I mean, you could put it there, and that would be a valid position. What I need to know, though, is that I actually assigned it. I guess I could. Ugh. 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 Yuck. If guard is null, throw new. Guard should have been assigned. What are you talking about?
Oh God, are you gonna do this to me, Valley? Jeez. You know, it's it's just simpler to do that. So, and I guess we could call him a guard. Them, sorry. I gave advice before, now I'm not even following it. All right. So if it's null, then we obviously did not do the right thing. So while we're not at the edge, what do we want to do? We want to say if the direction equals direction dot up, what do we need to do? We need to say, and we're good, because if we didn't break out of the while loop, that means our guard is not in a position that would cause us to fall off edges. So we're good that way. What we can do now is say if we're going up, if there isn't contained in the map at guard y minus 1, because those are the indices above us, contains, if it doesn't contain that, then we say positions plus plus. And now we say our guard is moved. Is a new guard where the guard's X is the same, but the guard's Y has moved up. And we don't change our direction. What's the problem here? Oh, shut up. Now, if it does contain it, now we say direction is to the right. And we don't change the position, the place of where the guard is, nor do we update the positions, the number of positions. So again, the map, y minus 1, if above it, if it doesn't contain any of the indices of where the guard, it doesn't contain the indices of where the guard is, then I update my position. Well, first we should move the guard, technically. And then, because it's going to be the same X, but we move up one, and that's a new position. Otherwise, we change the direction. So now I need to do that for all four. Else if direction is to the right, now we need to say we're at the same line, but does it contain guard's X position plus 1? Because we want to move that way. If it doesn't, now our new position is plus 1, same line, we do that. Otherwise, we go down. What do we do if we're down? We shrink. We go plus 1 here, but we say we're still at the same X. And so now our position would be the same X, put a new one there, and now we're going to go left. And now the only thing we can do is left. Let's be explicit.
So we're going to be at the same y, but we're going to do x minus 1. And if there's nothing there, we move to the left, staying on the same y, except now we're going to go up. We're always checking. Always checking. So we go to 6. We don't know what part 2 is going to do, so let's copy that out for a second. And let's get our test. So this is our test map. And for solution day 6, part 1, so this should do 41 distinct positions. Nope. Index was out of the yay! Woohoo! Yippee! Woohoo! Oh, yeah. Well, no. Oh. I think that's off by 1. Because let's say we had a 5 by 5. If I move down to row 4, so my y is 4. And I'm saying the count there is 5. Yeah, I'm off by 1. Okay. Still failed. 45. See, now, these are the ones I don't like. I either like it if it fails hard or if it just succeeds. If it is off by just 4 here, that's where I go, oh God. Oh no. Because I'm like, oh crap. Now I really got to debug this. And spend a decent amount of time looking through this to go, what did I do wrong? Well, we found the guard. We do eventually end, which is good. We are technically, let's get rid of 5 here. None of these have more than 1 in each one, but we should be doing that. Let's just kind of, I guess, step through this and see what happens. Okay, so we assume the positions as 1. We make our map. We make our guard. Like, seems fine there. Item is that. Indices is that. So we're at 4, right? 0, 1, 2. Yeah, that should be right. We shouldn't find any more, right? So our map was at 0. Our map is at 1. Where that has an index of 4. So let's actually speed it up. Let's get down to here. Our map has 10. That's 4. Second one should be 9. Third one doesn't have any. Fourth one should have a 2. Fifth one should have a 7, I believe. That doesn't have anything. Six has a 1, which is correct. This should be like 8. Yep. 8 has 1 at 0. And 9 should have 1, 6. So I think that's correct. I think that logic is correct. We found the guard at 4, 6. So X is 4. 0, 1, 2, 3, 4, 5, 6. We found the guard at the right spot too. Okay. So that's all good. The max X is 9, right? Because that there. And the max Y should also be 9 because we have a 10 by 10. Guard is not null. We're going up. So we don't do, so if we go up. Guard is 6. So we're going to look at 5. Does it contain a block? No, it doesn't. So guard goes to 5, and we update positions. I think I might know what's going on here. Which is when I change it to right, I think it's skipping into the else if. I'm not sure. Let's just keep going. So Y is 5. So I'm going to go to look at 4. Why did it do that? This whole testing platform thing, I'm not really grooving on because it's not that shouldn't have happened. So we say that, we pop out, come back in. So Y is 5. We're going to go up 1 to 4. And we're still at 4. Okay. So the guard should... Why did it... I'm thinking maybe it's a mistake to use this new testing platform right now because I don't understand how that would just cause the guard to wig out like that. There really should be no reason for that. Because we have a guard at 4-6. No, we have a guard at 4-5. Let's keep running. We have a guard at 4-5. We want him to be at 5 minus 1, 4, 4. Okay. Let's just fine go this way. I don't think I was saying like just go over and continue. Maybe I was. I'm not sure. Okay.
So we're going to update the positions. At some point, we're going to hit there. So Y is 1. If I look at this, that was correct. That's 4, 1. Okay. So guard should be 4, 1. We're going to go to the right. And we break out. Okay, so it doesn't skip out. That makes sense, because the if just says, if it's this, do whatever in that, go back. I just want to make sure. Right goes down, down goes left, left goes up. So if I'm going right, I'm on the same line, but I want to see if where I am, if the next thing that way is an obstacle. And if it isn't, then I make a new guard that moved. If it is, I go down. If the direction is down, I'm going to go down 1. Check to see if there's an index at that X position. And if there isn't, my guard moved down. Otherwise, we're going to go left. Left, we just do -1. Huh. It's 45. I am giving it the right input, right? Yeah. It's funny that it's doing that. That's just a font thing that's making that look like an ellipses in a way. Oh, distinct. Always read, reread, reread, and reread. And reread some more. So we don't want positions here. What we want to have is var guard positions is a new hash set of guards where we're going to add where the guard is. Like that. Now what we're going to do is say add guard, ignoring whether it actually happened or not. Same thing here. So we're going to uniquely track every position. And then we say guard positions dot count. Yeah. Now let's see what this does. Yep, passes. Let's do the big daddy. Did I grab 6? No, I didn't. All right, let's come into our program. Let's run 6. part 2 yet. So we'll say 6, part 1 of reading day 6 input. And what does that give us? Is that the right answer? Yes. Yes, it is. Part 1 of day 6 is complete. Okay. I've hit 2 hours, and I don't know if I'm going to get into part 2. Let's just take a look at it and see what part 2 says. While the historians begin working around the guards' patrol route, you borrow their fancy device and step outside the lab. From the safety of a supply closet, you time travel through the last few months, record the nightly status of the lab's guard posts on the walls of the closet. Returning after what seems like only a few seconds to historians, they explain that the guards' patrol area is simply too large for them to safely search the lab without getting caught. Fortunately, they are pretty sure that adding a single new obstruction won't cause a time paradox. They'd like to place the new obstruction in such a way that the guard will get stuck in a loop, making the rest of the lab safe to search. To have the lowest chance of creating a time paradox, the historians would like to know all of the possible positions for such an obstruction. The new obstruction can't be placed at the guard's starting position. The guard is there right now and would notice. In the above example, there are only 6 different positions where a new obstruction would cause the guard to get stuck in a loop. The diagrams of these 6 situations use 0 or an O, capital O. Yeah, you kind of have to have like a flare. So one above, one to the right, one to the bottom, and one to the left. One option, putting a printing press. Option 2, putting a stack of failed suit prototypes. Yeah, because here, if it would hit them. Option 3, putting a crate of chimney squeeze. I don't care, put an obstacle here because you would go up, hit that down. Because that would also get him stuck in a loop. It doesn't really matter what you choose to use as an obstacle. So long as you can put it in a position without the guard noticing. The important thing is to having enough options that you can find one that minimizes time paradox. As an example, there are 6 different positions you could choose. You need to get the guard stuck in a loop by adding a single new. I'm going to think over this on lunch. Because it's not just as simple as this one, where you're looking for this. If you're going up, there's an up, and then if you go to right, there's a right, and if there's a down, there's a down. This one requires you to follow the path, and then because he goes up, or they, and then boom, 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 and then all of a sudden they start doing this. This one's up, around, down, up, over, down, up, over, down, and then they get stuck there. This one is, but the one of the last ones is kind of tricky because you start up, down, but this one gets you back onto the same path. And this is you up, over, down, here, down, over, up, down. And you want to escape, but you can't, and now you're stuck here. I can't think of the answer off the top of my head.
You could do a brute search and just say, okay, let's make the map such that the obstacle is put here. Does the guard ever retrace their path? Or do they get out? If they retrace their path, that means they got stuck in a loop. I mean, that's one way to do it. I'll put that down as a to-do. It's not very elegant. We could create a whole bunch of arbitrary maps where we put obstacles at indices that don't currently exist. Then run the map. If the guard escapes, that's not a valid position. If the guard ever retraces their position on their route, that is a valid position. So again, with day 6, it's only 17K. And so you're just saying where we don't have an obstacle, put an obstacle there and just run it with this. It's brute force. I'm sure there's a more elegant solution to this, but I think this might work. But I am not going to do this right now. I am going to stop because my voice is shot. And if I go to self-defense this afternoon, I've got to do that this afternoon. So I'm going to just mull over this and see. I think this is at least a valid way to get to it. It just means that you have to do 17,000 simulations, which isn't terrible. I mean, we did this and we found on that map rather quickly-ish, that we found that there were like 2,000 odd, 5,000 odd distinct positions that the guard goes. And so we just find, did this affect the guard? Because it could affect the guard, but then you don't know if it will just make the guard still escape or not. So I'm going to go with that, but I'm not, that's one of the rules I also set for myself. I can think about this. I mean, my brain is going to think about it anyway, but that doesn't mean that I'm going to, doesn't mean I'm definitely not going to work on this unless I'm streaming it. I can make notes. I can, come up with different ideas or things like that, but I'm actually not going to do any work unless I'm on stream. So with that, I'm going to stop for now. If you're watching, thank you for watching. I greatly appreciate it. Or if you're watching in the future, either way, if you haven't subscribed to the channel, please do so. I would greatly appreciate that as well. And I will either be picking this up maybe tonight or this afternoon or both. We'll see. Either way, thank you all for watching. Take care, and I hope to see you in the future.